Thank you, Hillary. So I encourage you to join the Lakers if you're not a member now. We know who you are. So, and with that, I think what we'll do is we'll talk about tonight's discussion. So it's been a pretty crazy winter here. I know that we've gotten a remarkable amount of snow up in the mountains, and I think we have a good person to talk to us a little bit about what that means, and hopefully we'll learn a little bit about avalanches tonight. So there's a science to avalanche and understanding what happens with avalanches and how to mitigate their effects and predict them. And I think that I'm really excited about the talk tonight. So we have Erich Peitzsch. Peitzsch. Close. I'll let him say his last name again when he gets up here. Who's with the USGS up in East Glacier. And he's the former director of the Flathead Avalanche Center, and so he's been doing a lot of work at trying to understand how to predict and mitigate avalanche effects. So please welcome Erich.
All right. Thanks everyone. Thanks for joining us tonight. It's a beautiful sunny evening, so thanks for spending it indoors. So yeah, I'm a physical scientist with the Ecological Survey, former director of the Flathead Avalanche Center, and the new director is right here, Zach. You can raise your hand, he's needed. But Zach just got here yesterday, so welcome Zach. He's from Colorado. So anyways, yeah, so I'm going to talk a little bit about some of the research that we do on avalanches, including our collaboration with the Flathead Avalanche Center, which is part of the Flathead National Forest, as well as our research on avalanches as a landscape change driver. So what are the ecological effects of avalanches? Sean, could you, the next one is a video. Any good avalanche or any good presentation has to have a video, right? And the microphone should work right as well. Okay, so this is really loud. Okay, so this is actually in New Zealand, but it's a really cool video that a friend of mine took years ago. So you can see that they're in a helicopter, they dropped an explosive, it created a decent sized avalanche on this mountain, and in just a little bit you'll actually see the avalanche. You'll see the avalanche sort of fracture across the entire slope and propagate throughout this entire basin. Almost, so right there, you can just see it kind of shatter. Can everybody hear me if I don't use this? Yeah. Yeah? Alright. Great. So I showed this video. One, it's a really cool avalanche. And these guys, if there was sound, they're in the helicopter, they're a bunch of ski bumming patrollers, and they're really psyched that they just started this huge avalanche.
And they're in the helicopter.
And they're in the helicopter, the most important part. So these cliffs, for reference, are about 350 feet tall. So it gives you a little idea of the size of this thing. This thing traveled almost 3 miles down valley. So it went really, really far. And you can see it kind of, yeah, it does go uphill a little bit. It flows a lot like a river in some ways. But I like to show this video because it's one of the biggest avalanches that I've ever seen captured on film. Even though it was artificially triggered by an explosive. It's a cool one. This is actually in a national park in New Zealand because it affects the ski area. And so they actually use explosives in national parks in New Zealand. But this run actually comes into the ski area, so that's why they're doing avalanche mitigation in this area. Let's see if I can, oh no. We're going backwards. Okay, does anyone know where this is?
Right before the tunnel.
It's in Glacier. Well, it depends on how right before the tunnel relative is. So does anyone know where Red Rocks is? Along the going to Sun Road, it's now a new pullout. It's right there, exactly. This is a great crowd. I love this. So this is pretty typical for every spring along the going to the Sun Road. So in this presentation, I'm going to talk about avalanches as a hazard, and I'll focus a little bit on the collaboration that we have with the Flathead Avalanche Center and the Avalanche Forecasting that we do there, and then talk a little bit about the recent accident that had happened in Glacier Park this winter. And then I'll talk about our avalanche forecasting along the Sun Road, since it is spring, we're just starting that as well. So this is an avalanche along the garden wall in Glacier National Park. And the point of this is that oftentimes it seems like avalanches happen in pretty remote areas. You know, maybe they don't affect you directly. How many people actually ski in the backcountry here? Anybody? A few folks. How many people drive along Highway 2 over Moraes Pass in the winter? Okay. How many people know someone that either drives along Moraes Pass or skis in the backcountry? All right. So everybody is affected by avalanches. This is why avalanches are important. So they don't just happen in random slopes in really remote places. Again, in Glacier Park, along the garden wall. So along the Sun Road in 1953, two road workers for the Glacier National Park were killed in an avalanche in the Alps area. So if you're familiar with the going to the Sun Road, the area known as the Alps, so it's sort of just past Haystack and Big Bend, and that was in 1953. So not only did they threaten people and infrastructure, 1964 in the Rimrock area, just east of Logan Pass, a bulldozer was knocked off the road by a wet slab avalanche, and I'll talk a little bit about the different types of avalanches. Fortunately, you know, just an injury here, but I mean enough to knock over a D6 or D7 cat. It's a pretty big avalanche. So 2005 was the most recent close call, and this season's just starting, so knock on some sort of wood that we don't have any close calls or anything more than that this season. But in 2005, another bulldozer was moving across a slope that hadn't been plowed. It triggered an avalanche, and it took him just off the road. Fortunately, he was a very skilled operator. He was able to put the blade down on the bulldozer and didn't tip over anything. The hardest part was actually getting the bulldozer back onto the road level. And if you look close enough this summer, if you're driving the Sun Road and you're in the, you go through the Alps and you're kind of on that straightaway before you hit the Rimrock area before Logan Pass, if you look very closely and look down, you can actually see old machinery in Logan Creek. It's kind of hidden amongst the vegetation, so you have to spend a while looking for it. I think they might even paint it green at this point, but it's down there, so there is some remnants of some things that have gone off the road inadvertently. So you can see the two machines here along the road, and this is way down near McDonald Creek, along the going to the Sun Road. And this is from an avalanche in 2009. We had a weak layer in the snowpack, and in January of that year, 2009, we had a rain on snow event. It rained to about 7,000 feet. We had a huge avalanche, or it was a very widespread avalanche cycle, but a huge avalanche in the little granite avalanche path that we call it, Granite Creek. It came down, as you can see, all of the debris here. It took out pretty much an entire forest below the upper section of the road, went below the lower section of the road, and if you're familiar with Packers Roost Road, it actually went down past Packers Roost Road and almost reached McDonald Creek. So a huge avalanche. The pile here in April, 3 months later, was still 30 feet deep. So it was a pretty large magnitude event. And I'll talk about some of the research that we're doing on large magnitude events and avalanche ecology as well. I'll touch briefly on avalanches and climate. We're starting a new study where we're actually looking and using tree rings from these large magnitude events. We cut cross sections, and we're going to look at avalanches over time and some of the contributory factors. So things like not only large storms, not only how much snow throughout the entire season, but we're also going to look at things like El Nino and PDO, the Pacific Decadal Oscillation. These sort of teleconnections or these influences that may help us predict these large magnitude events or big avalanche winters like this. So again, I'm going to first touch on the avalanche forecasting, what we do at the Avalanche Center, and then the going to the Sun Road. How many people have ever checked out the avalanche advisory from flatheadavalanche.org? Awesome, that's great. We're winding down the season now, and Zach is our new director. He's going to take over next season. And he just moved from Colorado, from a very different snowpack to here in northwest Montana. And I haven't told him that it actually rains here in the winter yet, so maybe you can ease him into it. But we have a good collaboration at the USGS. I was the director for 3 years with the Flathead Avalanche Center and the Flathead National Forest. And we put out daily advisories for winter backcountry use. So I'm just going to touch on this season. As Sean mentioned, it's been in terms of snowfall, it's been an above average year. Right now we're hovering, just over anywhere from 100 to 120% of average for our snowpack. And that's a good thing. Good things for the summer. And if it happens, the melt happens gradually, then we should be okay with flooding. But right now, there's a lot of snow sitting in the mountains. So this winter, though, is a relatively typical winter, except for the fact that we went to the level of extreme once, which we've never gone to at the Flathead Avalanche Center. We got about 5 to 6 inches of snow water equivalent. So when we measure it's a way for us to measure sort of the weight put on the snow. We measure it in water equivalent, and it's how much water is in a column or a unit of snow. So we got about 5 to 6 inches of snow water equivalent within about 2.5 to 3 days. So that's a lot of water in a very short period of time. And it fell on a snowpack where we did have a leaf layer. So we got widespread avalanching pretty much everywhere. We went out after the storm, it was a sunny day, and you pretty much couldn't turn your head without looking at an avalanche. And they were big avalanches too. So it wasn't like sort of just small, shallow avalanches. Aside from that, we also had a fatality in January. I'm sure many of you heard of Ben Parsons, who was a good friend of many of ours, including those of us at the Avalanche Center. And I just want to kind of touch on that accident a little bit, because one, it hit close to home for a lot of people in the valley. Ben was very well known and very well liked. So I'll just kind of touch on some of the more, I guess, sciencey things, just so we have a sense of how our season developed, because it wasn't a huge winter pretty much it wasn't until February on. Before that, we were actually hovering well below normal, like 60% of our snowpack, and that sort of contributed to this accident, as I'll show you. Just a quick overview. There's Lake McDonald Lodge. The avalanche site is on Stanton Mountain, which is just northwest of the lake there. And it's kind of hard to see with this TV, but the crown, let's see if the pointer works. It won't work. It won't work? Okay. I'll point. This is the building. This is the ski hole. Where's my ski hole? Right up there. Anyways, the pictures are also on our website, but the avalanche occurred kind of in the main bowl, as you can see right there. You can see the debris right here. But Ben and his partner skied off the summit, and they were traversing over to the ridge. Ben actually made 2 turns, triggered the avalanche, and was carried down about 800 to 1,000 feet, vertical feet. He was actually spit out a little bit from the main debris pile, and the debris continued on down this tight, narrow gully where all the debris was forced into. Again, it's kind of hard to see. We can actually see the crown of the avalanche here, and it goes over a little bit. There's a ski track, and maybe it's just from where I'm standing. Maybe you guys can actually see. Okay, so you can see the ski track going across. All right, so it's where I'm standing. So the ski track goes across. You can see the 1 turn and then the 2nd turn. So he triggered it on the 2nd turn, unfortunately. His partner was off to the looker's right, just right of that ski track arrow. So Ben was carried down, his partner came down, and it's hard to tell, but this right here is pretty much just a little bit of snow on a lot of rock and bare ground. So his partner actually had to go off of the what we call the bed surface of the avalanche, so that he could descend the path to actually try and find Ben. So this is looking from the ridge. The next day, folks from the Avalanche Center went up and took a look at the accident site, took some measurements, and tried to piece together what happened in terms of the snowpack. So they went up this ridge the next day. You can see where it was triggered, just a little different view. So what happened was, a few days prior, we had a wind event that it was atypical winds for us. So they kind of came out of the northeast. Most of our predominant winds come out of the southwest. So we had wind loading on this southwest aspect, which is relatively atypical for around here. When they triggered the avalanche, it involved that new wind-loaded snow, but then it also stepped down to a weak layer near the ground. So again, this is the next day. It gives you a little sense of how large the crown was in some places. But it went from 1 foot or less in one location, and then here you can see it's 4 to 4.5 feet, and then it was quite variable. So because of the way the wind loaded, cross-loaded we call it, this ridge. What we wanted to do is actually try and use what predictor variables are important for wet snow avalanches, and actually use them in avalanche forecasting. But the problem is that as a forecaster, you're not going to look at the mean air temperature for the day and say it's over 5.5 degrees. Shut everything down. I mean, it's just, as we know, that's what statistical models do. Is they're great, but they're not always right. Well, very rarely. So what we can use it though is a good tool, and so we have. And we also tried to use it on a year where it was actually cool and wet, and we got wet slab and wide avalanches. But not because of warm, sunny weather. We got these avalanches because of rain. And of course the model just completely fell apart. So, there's always a lot more to do, as we know. But anyways, it was a fun study, and we're continuing to apply that model and refine it in our forecasting operations. We're also using time-lapse photography. So if you've ever gone to the loop and you've looked uphill and you see a little box on a tree, we've actually had some inquiries of that. People think we're actually spying on them, but we're not. Not going to testify to that, but we're not. But we're taking pictures of Peppa's Peak. So what we can do is we take pictures every 15 minutes. The camera's charged by solar power, so we take pictures every 15 minutes. And as you can see here, the red box indicates no avalanche on April 24th, and then on the 26th at 3:11 we had a small little avalanche, and then 2 days later, that huge avalanche released within 1 hour from 2:11 to 3:11. The problem with this tool is that on cloudy or rainy days we can't see anything, but it still works. So what we're able to do is, with those cracks that I mentioned, once those form, you can actually look at the number of pixels, the number of dark pixels versus light pixels, and you can see how the crack grows. And so that's one of the things we want to do is the crack actually growing right before it releases, and is it growing faster right before it releases? And so we can actually count the number of pixels per unit of time and see if we can do that. Right now, unfortunately, what's happened is these cracks will form pretty quickly, at least on this mountain, and then all of a sudden they'll release. So it's been a bit difficult to try and actually pin down what we call glide rates. So we're also looking at meltwater through the snowpack. We've set up what are known as lysimeters. So they actually track meltwater or water. So there are these trays that we put them at the bottom of the snowpack. So when water starts moving through the snowpack, it moves onto the tray and then into a tipping bucket. But as you'll notice, we only have 2 lysimeters on a huge slope like this. So we're only measuring 2 little discrete points, unfortunately, on a huge slope. But again, we're trying to use these tools that we're not going to put these lysimeters across the entire mountainside. 1, the Park Service won't let us. And 2, it's just not practical. However, maybe these 2 discrete points will be useful for us, and we can try and get some information out of it as some sort of proxy. So we set those up a year ago, and again, this will be our second season, trying to see if we can tease out any important information. Again, it all relates back to using this information as applied research for the forecasting program. There you go. So another paper we just put out is looking at the terrain parameters. So where do these glide avalanches actually occur? And all the red arrows are pointing to the glide avalanches, and they're pretty deceiving. This one down here on the bottom, that crown right there, how tall do you think that avalanche crown is? 500 feet tall? 15 feet. Any other guesses? We have 515. Anybody in between? 40. 40?
I'm at 20.
120?
No, 20.
20?
50.
50? $1. $1. He's right, it's $1. Well, obviously it depends on the year, but in this case, this year, it was about 60 feet tall. So Zach was close.
Yeah, all right.
Good thing he's the Avalanche center.
That's why he's made me in that position.
That's right, that's right.
I'm ready to.
So we also used another technology, photogrammetry technique called structure for motion. I don't know if anybody here has heard of it, but what it basically does is you take pictures with any camera you want. You can even use your iPhone, and you take overlapping images. Then you put it into, it uses a structure for motion algorithm. There's software that basically applies the algorithm that you want. And what we've done is, what it does is it creates a point cloud. So does anybody here know LiDAR? What LiDAR is? So LiDAR is basically light and detection and range and whatever else it means. What it does is it creates a point cloud. And that point cloud can then create a 3D model. You can also generate a digital elevation model from that. So what we can do is create a digital elevation model of this avalanche crown, and we can measure how tall it is by subtracting this from a DEM of the bearer, so without snow. So that's how we know how tall these avalanche crowns are. But in this study, we actually looked at, they're occurring in most of the same places. So why are they occurring there? And what are the terrain? What is the terrain? We kind of know what it looks like, but let's tease it out a little more. So this is from the loop. If you're looking north towards Trapper Peak, Vulture Peak, and Mount Cadune, that area. And so the red polygons there basically are blood avalanches occur there every year. And even though they're not along the road, they occur every year, so they'll give us an indication about, again, where these things are forming. What we found is that blood avalanches occur on smooth rock slabs, and that makes sense because as the water moves through the snowpack, it, again, moves along that ground snow interface. And if you have soil or any sort of grass, it can move into the grass or the soil, but it can actually move into the soil and percolate into the soil. If you have smooth rock slabs, it can't go anywhere but along that interface. So you basically, the water builds up there, and you're going to have faster glide rates on those rock slabs. So these areas, pretty much most of these polygons right here, are all smooth rock slabs. But the ones above the sun road, like near the garden wall, those aren't necessarily smooth rock slabs. They're bare grass, they're rocky soils. And so what we found is that those don't always form every year. And that makes sense because they're not smooth. So perhaps, the water's able to move into the soil a lot more readily than it is, or than it can on non-soil or rock slabs. So, anybody know where this is? John said I'll buy you a beer if you can guess where this is. No? This is a tough one. It's an avalanche in a river. This is actually along the Middle Fork at Goat Lake. So this is Goat Lake in 2014. This is looking from the bridge. And in 2014, I don't know if anybody remembers, but they closed the road and there were huge avalanches on pretty much March 3rd to the 5th. Big avalanches that took out a bunch of trees all over. And this one, in fact, went under the bridge. Fortunately, it didn't take out the bridge like it did in 1979. Was anybody here? Remember that one? Yeah. I wasn't either, but it's a big avalanche. Anyways, this one reached all the way down to the Middle Fork and it dammed the river. And so people were actually concerned because the water was building up behind it. But what water does best is find its the easiest way through, so it started to go under and around, but it was dammed for about 36 hours. Then it finally made its way down. But huge avalanches, so this is a rain on snow event. So again, as I mentioned, one of the things we're looking at is large magnitude events, and what are the contributory factors, and not only that, but how often do these things occur? And we only have an observational record, at least here in northwest Montana, that goes back only so far. So even along the John F. Stevens Canyon, along the railway corridor, up to Mirage Pass, the record, a good record actually only goes back, a very detailed record when they started the Avalanche Forecasting program for the railway, only goes back to 2000. So that's not very long. So what we can do is we can use tree rings to actually look at potential avalanche years. So you can see all these down trees. So there is this interaction between wildfires, what happens when wildfires move through an area, and then what does that actually do to avalanche frequency and magnitude, and how can that affect? That certainly affects the avalanche path and its characteristics. We also, as I mentioned, we're looking at avalanches in climate. So one thing we're doing is looking at dendrochronology, so looking at tree rings, and so the little granite avalanche path that I showed earlier with the bulldozers moving snow through that big green avalanche path, we took 100 cross sections from dead trees in that avalanche path in the runout, some greater than 3 feet in diameter. And what we're able to do is actually look for avalanche scars in these tree rings. So you can see where it says 1993 1. So that's the best signal. 1 is like the highest quality signal that we're going to get in the tree ring record. You can see that it's basically a scar. So what happens is, on the uphill side of a tree, if an avalanche comes down, hits the tree, and the tree, as it's not growing in the winter necessarily, but it's still, once it starts growing, will actually buffer itself. And you can see on the downhill side, 1993, how that reaction wood is pretty thick. So that ring is a lot thicker than it is relative to the year before. And so it's not that it was a big growing year and it was a huge, that it grew a lot that year. It was because the tree was actually buffering, and because it got hit on this side, it was then compensating on the downhill side. So this is a good example of an avalanche scar in a tree ring. There are some other signals as well. You can see where it says 4 there in 1985 and 1990 that aren't as obvious, but the one in 1993 is pretty obvious. So that's how we can actually look under a microscope, and we can count all the rings, figure out how old the tree is, and then if we have enough samples, we can actually cross-date the trees in the path to take samples outside the avalanche path, we can cross-date it so that we can match up the years, and then we can develop what we call an avalanche chronology. So we can see when these large magnitude events actually occurred, because we're taking samples far down in the avalanche path where only big avalanches are going to reach. So then what we're able to do is actually create a return period or frequency throughout the avalanche path. So this is in an avalanche path in avalanche path 10-7 along the John F. Stevens Canyon corridor. The black rectangle there is the snow shed. We have our trees, and as you can see, all the way down to the snow shed, our return frequency is pretty high. So we're a pretty low frequency rather. We're looking at basically anywhere from 14 all the way up to 100 years as we go further past the snow shed. Whereas higher up in the avalanche path, so closer to the top of that, we have much more frequent avalanches higher up the path. So it allows us, as we collect these tree cross sections up the path, it allows us to get a frequency or return period map. And this helps because people want to know, well, how often do avalanches, or how often are they going to hit the railway? How often are they going to hit the road? How often are they going to take out huge swaths of forest areas? So this enables us to try to get an idea of the biggest avalanche years that are occurring. Slide paths like this here, this is on the east side of the park, just outside of St. Mary, the St. Mary Lake. They also work and they deliver organic and inorganic nutrients from the subalpine all the way to the mountaintops to the riparian zones. So big avalanches like we saw earlier, these wet slabs, which often fail near the ground, can drain soil and basically move nutrients quite quickly from the alpine to the riparian zones. Here's an example on the Heaven's Peak, the other side, which I was showing you earlier. This is along the Going to the Sun Road. A huge avalanche comes down. This one dammed McDonald Creek for a while, and it came up the other side, buried the road on the other side of the creek, and as you can see, took out a huge amount of forest. So avalanches play a pretty big ecological role. This is basically snow, it's avalanche debris covered by vegetation debris, trees that were brought down by an avalanche. They are 20 feet deep, and this actually, in the Little Granite Avalanche path in 2009, the snow in the runout zone persisted over that summer of 2009 into the winter of 2009-10. So they kind of create these little local reservoirs in that area. So let me go back one. Let's see. I'm trying to remember what lake this is. It's Logging. I think this is Logging Lake. So avalanches come down and often end in these lakes. They're creating suitable aquatic habitat. Clint Malfeld, who spoke at one of these talks a little while ago. There we go. So his red dots are basically fish habitat. Don't get me started on living things because I don't really know living things that well. I just like snow and ice. But these are fish. The red dots are fish. That's what Clint told me. They're fish. Just remember, they're fish. So they're breeding grounds for fish, and they like to breed there, I guess, because this is where all the nutrients are. Because we're bringing nutrients in the avalanche path right at the base of this avalanche path into the lake. So avalanches sort of do things and create habitat that we don't necessarily expect. So in 1979, you can see what this is again above the railway. Let's see, this is shed 5, I believe. And then in 2004, reforestation occurred. So where do you think we're going to see more avalanches, or at least more frequent avalanches? The left picture or the right picture? Yeah, it's just more open terrain. Not as many anchors. We don't have many trees to help anchor the snowpack. We still do see avalanches here, but certainly more over here. So reforestation has an impact on avalanches. So it's sort of the cycle that we see. And this is shed 7 in 1997. A big avalanche came down between then. Took out a huge amount of trees. This is in 2004. It looks pretty similar to that now as well. Even here, 2017, 13 years later. So, that was a little long, sorry. But anyways, yeah, I just wanted to kind of show you avalanches. People often think of avalanches as just a hazard, but they also have an important ecological role. And especially here in northwest Montana, we have so many areas. Unfortunately, not a lot of them are where humans recreate, or that's where we recreate, but it's not necessarily where we travel or where we live. But yeah, that's all I've got.
Again, thank you very much. That was excellent. I found it very, very informing, and it's something that I don't think about. I tend to focus on the living things, that you talk about.
We make a good team.
Yeah. But we have plenty of time for questions. Just point to folks, and please, if you don't, shout out your questions so everybody can hear them here.
I'm always curious about the snow sheds for the trains. How come the avalanches don't take them out, or do they?
Did everybody hear that?
So hardly built well enough to.
Yeah. So the question is the snow sheds along the railway. The question is, why don't avalanches take them out, and how are they built basically? Unfortunately, I'm not an engineer, so I can't address it with any sort of structural integrity, no pun intended. But to my knowledge, the way they're designed is they're designed enough so that they're flush with the avalanche path. So they basically act as if the avalanche is traveling over the ground. So they're not completely flat. They do have some sort of slope to them. And then, of course, if you look at the avalanche paths, or the snow sheds, you kind of look at them, and a lot of the beams are still wooden beams. And so, but they do collapse at times with a big enough avalanche. But the one, they're also continually reinforcing them with concrete beams now. Yeah, I think it's just they know how to build them quite well, so they've persisted. However, I guess I will say this is that when I showed that picture of the reforestation on that where the one snow shed was, what happened there is that whether it be wildfire, not deforestation in the park, but maybe in other places, but if an avalanche comes down, for the most part it'll go over the snow shed, but in places where we call it the trim line, the difference between the avalanche path and the forest. But if that trim line exceeds the width for whatever reason, a huge avalanche, the avalanche can actually come down the sides and still hit the track, but then fill in the sides or backfill the opening, because the downhill sides of the snow sheds are open. So if the avalanche comes down over the snow shed, you can actually backfill it and still get into the shed in time. So they're not, they work, but
They're not perfect.
they're not perfect. Yeah, they're not a tunnel. Yeah.
So you said that you don't use explosives for your avalanche control, but I thought on Highway 2,
Yeah.
they do some use of explosives for mainly the train tracks, and they did quite a few times this last year, right?
Yeah, so it's a great question. So they can't use them on a regular basis. What BNSF Railway has to do is they have to apply for an emergency mitigation application for the Park Service. So it basically means that life-threatening avalanches have already hit the railway and are probably going to occur again. So every time they do that, they actually have to go through an application process, an emergency application process to the park. Fortunately, it's an emergency one, so it doesn't take as long as it might in other application processes. So, so this year they did mitigate once. They were going to again, but they at the last minute decided not to because the hazard had decreased and stability had gone up. So they didn't have to. They didn't have to use mitigation the second time. But along the going to the Sun Road, we don't use mitigation there. And along the BNSF Railway, what they've chosen to do is use a device called the Daisy Bell. So it's basically sort of this bell-shaped thing, that just hangs below a helicopter on a long line, 100 feet or so below the helicopter. And it creates an explosion of oxygen and hydrogen inside the tank. It releases and it creates an air blast on the surface of the snowpack. So that's what they use as a mitigation tool on the slopes above the railway.
So why couldn't you do that on going to the sun?
It's a great question.
I mean, especially since we have overcrowding because the season is so short. And compared to other highways, they're open much earlier than going to the sun. One of the things that would help the workers is to do some avalanche mitigation to save those workers from getting shoved off the cliff.
Yes.
Superintendent Mao was here a few weeks ago.
Yeah, why did you ask him that question?
I did ask him that question.
Well, what was his answer?
They need to kind of look into it.
Yeah.
Because you look at the Beartooth Highway where I grew up, it's open at least a month, if not a month and a half earlier. Same conditions, 4,000 elevation higher than you go into the sun. In my opinion, there's no reason to go into the sun kind of earlier to spread the traffic out to relieve the congestion. Because the worst national park that I've been to is Yosemite.
Yeah.
Because of the congestion.
Yes.
Or Race, Montana, and do not like lots of people in the same place at the same time.
Yeah. So I mean, it was interesting because I don't remember the exact year, but I think it was in the 60s where Glacier had decided to not allow snowmobile use. Yellowstone decided to allow snowmobile use, and then later on, Glacier Park had decided not to use explosives, and Yellowstone decided they would use explosives over Sylvan Pass, mostly for snowmobile recreation from Cody, from the east side over to into the park. So it's just, it's basically management strategies and how they chose to interpret their wilderness management and how they chose to interpret it basically. There are things that they do. Explosives aren't unprecedented in the park. They use them on trail crew at times to blow up snow drifts. But I think the reasoning, to my knowledge, occurred before I got there. The decision was before I got there, unfortunately. But I think that's the way they chose to interpret their decision or their management.
How are you guys funded?
So the USGS. We are funded by the USGS, and we do have some other agency and entity grants, but primarily through the USGS appropriated funds.
The USGS is funded through the Department of Interior, right?
Through the Department of Interior, through appropriated funds. So the budget comes down all the way from the top.
Are you worried? Yeah.
Next question.
Yes.
I have a question about the glide avalanches you were showing.
Yeah.
I'm wondering if in warmer winters you're finding that there are more rain on snow events make them more likely, or if you're finding that it actually makes them less likely because more water gets into those bare grass areas and prevents them.
Yeah, I wish I knew the answer. That's what we're trying to learn now is, is what, we did that study looking at wet slab and glide avalanches. There's actually been a more recent study that is from Switzerland that has shown that we're not only, we're talking about sort of spring glide avalanches here, but they also looked at glide avalanches that occur in the winter. And that's actually happened here too. 2 years ago, we had a glide avalanche cycle in November. And what might be one of the causes there is that we actually have, from the soil-snow interface, we actually have the snow acting sort of via capillary action, pulling water out of the soil. Especially if you have a relatively warm spring or warm fall, and you get big storms in let's say mid-November or something, relatively early. But if we get big storms on top of that, but the soil in the ground is still relatively warm, then we can actually have that layer, that interface is still pretty warm. We can actually have water being sucked up into the snow, creating, instead of water coming from the surface down, it's actually brought up from the soil, and we can create that sort of lubrication there in that ground snow interface. So, but getting back to your question about the rain on snow, that's one of the things we want to try and tease out is, are we going to see more of these because of more rain on snow events? Or also, a colleague of ours, Greg Peterson, showed here, at least in the northern Rockies, that basically the winter is shortening, particularly on the spring inside, by 2 to 3 weeks. And so at least the NOUT study was in 2010. So we're going to see more of these wet snow avalanches creep into what we consider the winter because of the earlier onset of spring-like conditions.
So do you guys focus this time of year? Do you focus on the dormant sun?
Yeah.
And try to help them avoid dangerous situations?
Yeah, and so again, it's all forecasting based. So we're looking at everything from contributory meteorological factors, air temperature, solar radiation, rain, and it's basically a go or no go decision. We don't make the decision. We inform them about when we think it's a good idea or not. We actually have a hazard scale that we use for the summer.
So do you hike it, or do you mainly look at the weather conditions?
Yeah, we go up there too. Yeah, we go.
You cut slabs and...
Yeah, we do stability tests, so we'll dig into the snow, and it's quite different than dry snow because, as I mentioned earlier, we're not looking at an increased stress on the snowpack. We're actually looking at a decrease of the strength of that that layer if we have a weak layer. So what we do is we'll dig snow pits, but we want to see sort of where the snow is in the snowpack, or where the water is in the snowpack. So, as it moves vertically in the snowpack, it also moves laterally and horizontally, of course, maybe along an ice crust or other layers. But as it does that, we kind of want to see how it's moving through the snowpack, and has it reached the ground yet? And if so, when it gets really warm and really sunny, what's the water doing then? So we do a variety of things, from stations to digging in the snow as well.
So I was just going to ask, could you walk us through a typical investigation at a single site and what you do to assess either the hazard or what you're looking for within the pack itself?
Yeah, so it's a pretty big toolbox. Like for forecasting is what we use. So for recreational forecasting, we're not only using what we see in the field, but we're using observations from the public and what they send in and what they've seen out there. But when we do go into the field, typically it sort of depends on the avalanche problem that we're looking at. So if we're concerned about wet snow avalanches, we may just go out and try and see as much terrain as possible and see where these wet loose avalanches are occurring. Because they're just superficial avalanches. They're pretty much just the snow surface. But if we're looking at wet slab avalanches, then we might dig into the snow more and see where water's moving through the snowpack, see if some of the grains are so wet that they're becoming much weaker than they were the day prior. So we'll dig into the snow, dig snow pits, maybe perform stability tests. So we'll do where we isolate columns of snow about 90 centimeters wide, or 30 centimeters back into the slope. Perform some stability tests where we actually tap on our shovel. And that again is more looking at the, how much force is it going to take for that weak layer to break. However, there's other tests where you can run, snow saws, that are about 30 to 50 centimeters long, where we can run along the weak layer and actually sort of decrease the strength. So that, we try to use that for wet purposes to see if that's going to, decreasing the strength is going to have an effect. So it sort of depends on the problem, what we're looking at. Well, again, some days are more just trying to see as much terrain to see if we had avalanches, and other days are kind of focused in more pits. So we might take a bit here on one aspect, move to another aspect, and dig over there, or obviously dig throughout the day, dig holes in the snow throughout the day to see how maybe the sun and warm temperatures are affecting it, or how new snow is affecting it. So it varies.
You guys been able to use the power of drones in remote areas to get eyes on target or use the LiDAR from drones. It's a big deal because National Park Service limits the use of them.
Yeah.
But I'm not sure if you've partnered with any people to help you out.
So we haven't yet. So one of the projects we're working on is using structure for motion. So to create that point cloud, so we want to use drones in the Highway 2 corridor. So we figure if we go straight up and not go into the park, then we should be all right. And however, I heard a rumor that they were either entertaining or they have used drones in Grand Canyon for scientific purposes. And if you know about this, then we should chat. Perfect. And so yeah, I'd like to. I think perhaps the park might be into it if it's used for science in a non-populated area. So, yeah, let's check.
Yeah, a lot of the national park limitations are so that they don't interfere with people's experience.
Right.
But in winter, when nobody's up in
Yeah.
glacier,
Yeah.
it's a perfect opportunity.
Yeah, I agree. Jim,
Have you ever been in an avalanche?
I have.
Exposed.
Yeah.
Describe.
So I've been in two. Fortunately, I'm still here. One, I was a ski patroller in Lake Tahoe for a number of years at Alpine Meadows, if anybody's familiar. And we're conducting our morning routes, or avalanche control routes in the morning. And I was skiing out to look, or to quite far away, about 15 feet away from the edge, where we know a cornice is formed, and we were about to take an explosive and put it on the slope and trigger an avalanche. The cornice broke way back further than I expected, so fortunately I was on top of it. It was a big cornice, at least probably 3/4 of the length of this room. Fortunately I stayed on top of it, and it broke and triggered a small avalanche on the slope below. And then the second time, when we go out, we try and choose slopes that are low or no consequence, what we call test slopes. So if something does happen, it's not going to be a big deal. So we were up in the Red Meadow area, in the Whitefish Range, if everybody's familiar, and moving across the slope, well below tree line. But we had a layer of surface ore. So those feathery crystals that form on the surface, they're great on the surface. But once they get buried by enough snow and they have a slab on top, then they can become dangerous. So, of course, we had a big avalanche cycle, and as forecasters and scientists, we want to go out and see what happened. And we rode in on snowmobiles and looking around, and there are avalanches, quite a few. And we're like, oh, this is great! There are avalanches. Our forecasting was right. So we got to the slope, but what we wanted to see is, are we still, the areas that didn't slide, are they still unstable, or what? Do they need still more of a load, or what's the deal? So it was a very small slope within a little opening in the trees. I was with my partner, and I sort of dug a quick hand pit, and I saw that there was a surface ore layer there. And I said, all right, I'm just going to go out a little bit and dig a pit, and we'll take a look. And it was a very small slope, half the size of this room. Well, no, not the width of this room. And then, the vertical fall wasn't very big, 20 to 30 feet. So I went out and dug my pit. I dug about 1.5 meter wide hole, and it was about a meter and a half or a meter deep because the layer was about 40 centimeters down, so it was a meter deep. And at that point, I told my partner to stay in a safe spot by this island of trees on this little sub ridge. And then I told him, I was like, all right, come on over. And my skis were off, and he came over. And he was going to go around me to get to a spot, take his skis off, and we were going to perform our stability test in the snow pit. So he walked around me, and as he walked around me, we heard a whoop. And how many people here have experienced a whoop before? Yeah, it's not a very good feeling when you're on the slope. You know, if you're on a safe ridge and you feel it, what that is the weak layer collapsing, and the whoop sound is actually air being pushed out of that layer. So we heard the whoop, and then the snow, or the avalanche, or the slope collapsed, or the slab collapsed, the weak layer, the avalanche released. We were about 15 feet below the crown when it released, and my partner was on his skis with his skin still on the bottom, so he was able to kind of ski to the side. But I didn't have skis on. I tried, but it was deep. So the avalanche sort of pushed me, but it was again a low consequence slope. So it pushed me downhill, carried me 10 feet or so, maybe 15. But it definitely pushed me over, and even that small of a slope, it started, pushed me down and started crawling up my back, the debris. So it buried me up to about, almost my neck on my back, but it wasn't very deep. I was able to actually stand up and shake free on my own. But, again, it was a great reminder that we are out there, and while we're searching for data, we always want to collect as much data as possible. That one, often it's not worth it. And two, that this is why we choose small slopes. And if it was a bigger slope, it could have been a very different outcome. So yeah, unfortunately in this field we're often reminded of not only the fragility of human life, but also that we're facing a phenomenon that we don't fully understand. We can often be surprised by it or blinded sometimes.
How accurate is avalanche forecasting?
99.9%. I wish. I don't know. I wish I knew. I don't know what percentage. Zach, do you?
75% of the time.
Off the cuff? Yeah,
It sounds like 60% of the time it works every time.
that's right. Yeah. I think there are days where it's 100%, and other days where it's not 100%. It's still such an exact science.
Do you know when there's a day that's not 100%?
Yeah, so we do, and so we can do like in the recreational advisories. We try and state the uncertainty, or like, look, we just don't know whether it's because we don't know how much snow we're gonna get, or wow, we thought we were gonna get 6 inches overnight, but we got 12. And the storm's still going. And are we gonna get more, or is it finally gonna stop? So that's just an example, but we'll try and state that uncertainty and let the public know, like, this is our best estimate right now of what we can. If you look at the North American Public Avalanche Danger Scale, it's, it goes from low, moderate, considerable, high, and extreme. So 5 classes again. And there's sort of, it's based on 3 things. One, it's based on the likelihood, the probability, size and distribution, and then the travel advice. And so with the recreational crowd, we try and tailor it to the travel advice. Especially if there's uncertainty, we'll go with, look, here's the uncertainty, and here's the travel advice associated with that danger rating, and use it appropriately. I think people are getting it. The danger scale was revised in 2010, and I think people are starting to apply it more.
So one suggestion I have is for my first 20 years as a skier, I didn't know what that wolf sound was all about. It wasn't until I became the ski patroller that I realized that that's the indication that you're in an avalanche zone. And I think you better get the hell out of there. Kind of thing. So I think getting the word out to people. If you do nothing but tell people that sound is a bad indication, and you need to get the heck out of there.
Yeah.
Second part of the question is, so the accident in December, there was an experienced guide. Why did he go on that slope, being an experienced guy, and get caught in an avalanche? I know it's not 100%.
Yeah.
But as an experienced guide, you should have been looking at all the indications, the loading of the slope, the weather conditions prior, all that stuff. How did he end up being in that area? Was it something unusual or?
Yes.
Okay.
It was, but that's a great question. So I actually just presented that, pretty much this exact question at a workshop last week in Bozeman, where I presented the accident, the objective information, and then it was to a group of Avalanche professionals, so forecasters, ski controllers, guides, and researchers. And so in my presentation, what I asked the audience was, what does experienced actually mean? And so, stepping back from your question into what does experienced mean? And so, when we write this report, we said, experienced skiers headed out. So, yeah, they're experienced skiers, but then we try to distinguish, and whether it be skiers or snowmobilers, snowshoers, climbers, whatever, we try to distinguish that with, well, what's their level of avalanche experience or avalanche education? And, in this case, Ben he had taken a level 2, so there's level 1, 2, and 3. And you take a level 3, you're kind of on your route to being an avalanche professional. Ben had taken a level 2, and he wasn't an avalanche professional, but he had taken sort of the upper end of the recreational curriculum, so to speak. And he got out of the mountains a lot and traveled a lot of the mountains. But the reason I answered your question with yes is because it was unusual. As I mentioned earlier, we had atypical winds. Our predominant winds are from the southwest. In that case, they came from the northeast and they were pretty strong. And that was 3 to 5 days prior. But what happened on this slope, it was early January. December was, air temperatures were well below average, and snowpack was actually around average the first part of December. So we had enough snow, but the air temperature created, because it was so cold, we had 3 Arctic air masses come in from Canada, and as you guys know, from experiencing, it was a cold December, even into January. So what that did is basically it created a weak layer in the snowpack near the ground. That weak layer near the ground, especially in areas of a shallow snowpack, continued to get weaker and weaker in later December into early January when we didn't have snow. So then we got winds from the northeast with a little bit of snow, and basically carried all that snow, wind loaded that southwest aspect, which typically doesn't get wind loaded. So 1, that was unusual. 2, it's pretty unusual that our Decembers are actually that cold and create that weak layer. We just don't get, every winter we typically don't get that weak layer near the ground. Like in Colorado, it's a different story. They deal with that thing all winter, and I'm glad I don't live there. But here, it's rare that we get that. And it didn't last all season here. It lasted in the early part of the season, and then that layer finally got buried deep enough that we weren't impacting it, and it got warm enough. So yeah, it was unusual. That location, again, because of the atypical wind loading patterns, there was a lot of uncertainty that day too, in that it was rated moderate, so that basically that means that human triggered avalanches are possible, and that basically you need to dig into the snow, look around, and be careful evaluation of the snowpack is what the travel advice says. It's kind of broad, but that whatever it takes to evaluate it carefully. So in that case, I think the uncertainty was high, and when the uncertainty is high, what do? We should choose lower angle terrain, maybe safer terrain, places that aren't as exposed. So in that case, I think their intention, when we talked to Joel after the fact, their intention was to ski over to the ridge and then ski down the safe ridge that they ascended. But I think, that Ben made those 2 turns, as you can see in the picture, and unfortunately hit the sweet spot on that second turn. And I think his intention was to make a couple of turns and then cut across back to the ridge. But
So they hiked up there. They didn't get dropped off by other ducks.
no, they hiked up.
Did you see any signs that they dug any pits?
No, they didn't. Joel mentioned that they were looking at it, they were kind of feeling around, they dug a quick hand pit as they came off the top, skiing down, just to see what was going on. And what he stated was that it was so variable. It was really shallow in some places where they were almost hitting the ground through the weak snow. but then deeper in others. And he said that they didn't dig because if they dug in one place, it might not be representative of another. And so in that case, one argument is that, well, maybe we need to dig more snow pits in general when the uncertainty is higher, when the variability is higher.
We'll take one last question over here.
Yeah.
So what can you do or carry with you to help you venture in an avalanche?
That's a
I
great.
think you should expand that question to like a top, maybe 3 tips for people.
Perfect.
Good questions.
But
That's surviving.
well, the media always asks in interviews, like, do you have anything else you want to say? And I was like, yes. And that's always what I say. So you should always carry 3 things when you're traveling in the backcountry: an avalanche beacon, an avalanche shovel, and an avalanche probe. The shovel should be metal. It should be a strong shovel, not just a shovel you buy at Costco or something like that. And then those are the 3 main things you absolutely have to have. But not only that, not just carry them, but know how to use them. So know how to use the beacon. Practice your beacon. If anybody skis in the Whitefish Mountain Resort, at the top of the ski resort, we have there's a beacon park up there where you can actually practice your beacon. There's 8 or 9 varied beacons, and there's an electronic box. You can turn on one and go search for it, come back, turn on another one, turn that one off. So know how to use the equipment as well. And then, of course, there's other things like airbag packs or Avalungs that you can use as well. Those are the 3 main things for sure.
All right.
Thanks, guys.